So we just got done with adding and subtracting, and we're going to talk about multiplying and dividing now. Just remember that since I is the square root of -1, all the radical rules still apply. So this stuff should be super, super easy. Just remember to simplify when you see I squared. So all these problems will line up to what we're going to talk about and what you're going to see. So, just as it looks, we're just going to end up distributing this term into both the 5 and the 7i. So it's going to be negative 15i minus 21i squared. Of course, I squared is just -1. And so then the final answer is going to be negative 15i plus 21. The standard form of this would be 21 minus 15i, but it doesn't really matter which way you write it. Usually the real part of the complex number is written first and then the imaginary part, but as long as your signs are correct, then it doesn't really make any difference. So make sure you FOIL all the way on a problem like this and just watch your signs. The 6 times 3 is going to be 18. 6 times positive 5i plus 30i. And now we're going to move on to the next term. 2i times 3 is 6i. And then 2i times 5i is positive 10i squared. Make sure you simplify any place that you can. So we have two like terms here. And we also have the I squared that we're going to have to deal with. So 30i plus 6i is 36i. Again, I squared is really -1, so that's just going to be -10. And now we're going to finish off and combine these two terms. 8 plus 36i. So pretty much any problem that you're going to see is going to be able to be reduced to at most 2 terms. That's not all problems always, but for what you're going to see, 2 terms is the most likely time. So make sure that you continue on after this step and make sure you get it all the way simplified. So this problem is basically the same. You just have to remember that the exponent here means that you have to rewrite this whole group twice. And if you remember to do that, then it's a super easy problem. It's exactly the same as the one we just did. But you have to remember to do this, otherwise you're going to be missing a couple of terms. So -3 times -3 is 9. Then we go to the -2. -3 times -2 is positive 6i. Now we move on to the -2i times -3, so positive 6i. And then finally a positive 4i squared. Remember, you're going to be able to reduce this down to 2 terms, so just make sure you do. So we have these 2 terms, and again the I squared. So we have 9 plus 12i minus 4 now. And then finally 9 minus 4 is 5 plus 12i. So at first glance you might not even think that there's anything that we have to do with this problem. But remember that I is actually a radical, and just like any other radical, you don't want to leave that in the denominator. So we have to multiply the numerator and denominator of this fraction by something so that we don't have I anymore. Since we only have one term, we don't have to worry about the conjugate here. And you could multiply really by any term that you want that has an I in it. So you might say, well, I'm just going to multiply by 3i over 3i, or maybe even negative 3i over negative 3i. None of that is incorrect, but you would have to simplify a little bit later. You're making up this number, so you might as well just do I, because as soon as we can get I squared, then that will be able to change to negative 1, and we will no longer have a radical in the denominator. Just make sure that you distribute when you need to distribute. So 6 times I is going to be 6i. 8i times I is 8i squared. And then 3i times I is 3i squared. Now make sure that you reduce from here. We have 2i squareds. So the numerator is going to become 6i minus 8. And the denominator is negative 3. You should definitely check to see if these three can all be reduced by the same number. In this case, they cannot. But again, if you decided to multiply here by 3i and 3i, that wouldn't be incorrect. But then these would end up being multiples of 3, and so then you would have to reduce on the last step. So we have the same issue on this problem as we did on the last one. We have this I in the denominator, and remember that I is a radical, so you don't want it down there. But now we do have two terms, so this is where the conjugate comes into play. All you're going to do is use the same two terms, but change the sign in the middle to the other sign. So since we have a subtraction here, we're going to change that to a plus sign. 6 plus 7i, and 6 plus 7i. And again, we can do this because that's just a form of 1. So you do have to remember to FOIL and distribute. So we're going to take the negative 4i to both of these, and that's going to give us negative 24i minus 28i squared over, and make sure you FOIL down here, 36 plus 42i minus 42i minus 49i squared. Just watch your signs when you're doing all this. Again, the whole point was that these two are going to cancel themselves out. That was the whole idea. The numerator is going to simplify into negative 24i plus 28, and then we're going to have 36 plus 49, and again, it doesn't matter to me if you write the imaginary part first, but usually in any answers you're going to see the real part of the complex number first. Let's say 70, 85. And this is a good answer. You also may see that they break this into two fractions. So this is equivalent to 28 over 85 minus 24 over 85i. And so sometimes you'll see it written like that. These are equivalent. This is perfectly good. But if you wanted to know what the real part of the complex number is, and the imaginary part of the complex number, then maybe you'd write it like that. So this problem is almost identical to the one before it, the only difference being that we're going to have to FOIL both the numerator and the denominator by the conjugate. Again, the conjugate is just the opposite sign of the two, the opposite sign of the one between the two terms in the denominator. So this is going to be 8 minus 9i. And just remember to FOIL and watch your signs. So we're going to get negative 16 plus 18i minus 56i plus 63i squared. And that's going to be all over 64 minus 72i plus 72i minus 81i squared. It's very important to pay attention to your signs. Again, the whole point of the conjugate is that these two terms end up canceling themselves out. We have a lot to simplify. So in the numerator, we're going to have negative 16 minus 38i. And then I'm going to change the I squared to a negative 1, so minus 63. In the denominator, it's going to be 64 plus 81. And then we're just going to combine any more like terms. So the numerator is going to be negative 79 minus 38i. And the denominator is going to be 145, I believe. Again, you should check to see if all three of these terms, all three of these can be simplified, divided by the same number. I don't think they can off the top of my head. It doesn't look like it, but you should always check. So just as a refresher, remember that I is equivalent to the square root of negative 1. I squared is equivalent to negative 1. I cubed is equivalent to negative I. And I to the fourth is equivalent to 1. Okay, and so these are the ones that you would give as your answers. The other ones are just for reference. So make sure that none of your answers have where I is an exponent of anything bigger than 1. And so there's a couple problems that you might want to think about. And firstly, the difference between these two is hopefully understood, but just in case it's not, that's supposed to be a 3. Just in case it's not, these parentheses make a big deal, or are a big deal. This problem is saying negative 1 times I raised to the 34th power. This question is saying, or this problem is saying, take negative I and multiply it by itself 34 times. So negative I times negative I times negative I times negative I times negative I 34 times. So there's a big difference between these two problems. Okay, so both of them should be done basically the same way, but the 34th power, right, this is where you want to take the exponent 34 and divide it by 4. And you're going to get 8 and 2/4. Okay, and so that's going to be the second step here. So this is really negative 1. Okay, so that negative out front doesn't get affected by the whole process of raising I to the 34th. So then the answer to that one is just going to be 1. This problem is going to be a little bit different, right? The first thing you want to remember is that if you raise any negative number to an even power, it's going to be positive. Any negative number raised to an odd power is going to be negative again. So the first thing that you would want to do is raise negative I to the 34th power, which would make it I to the 34th. Again, a negative number raised to an even power makes it positive. And then we're going to still divide by by 4, and it's still going to be 8 2/4, which still gets us to the second step. And so I to the 34th is actually negative 1. One more of those problems. So negative I raised to the 37th this time. Again, that's different than this. These are not the same. So in the problem that we're looking at, negative I is going to be raised to the 37th power. Since it's a negative number raised to an odd power, it's going to remain negative. So then it's actually going to become negative I to the 37th. Oh, so I guess they are equal, really. Hilarious. Anyway, it's not the same idea, but it ends up being the same in this one. Anyway, the point is that you have to be careful about where your negative is with relationship to your parentheses. But what we're going to do is take 37 and divide that by 4, which is 9 1/4. That takes us to the first step. So I to the 37th power is actually I, but since we had this negative out front, it was no longer in the parentheses. The actual answer to this is negative I.